Okay, so sorry I'm not here today. I had some pressing family issues to go to. So anyways, this is your notes for today. We're gonna review our homework. I'll go over that with you guys here, and then we're gonna do some notes and some classwork, and then we'll take a group quiz. I don't think we're gonna have time to grade the quiz, and we'll grade it next class. Okay, your homework is investigation 4 ACE question number 1. It should be in the basket when you came into the classroom. It's a half sheet, and the questions are already set up for you guys, ready to go. Okay, so that's your homework. I'll go over at least the homework with you guys, a couple of the questions that I know that a lot of people had trouble with, and I'm going to go over the notes with you guys as well. And then the sub will hand out the quiz. And I'm going to go over a couple of things on the quiz that people are getting confused on, just to review. All right, so it's Termite's favorite breakfast. I'm going to go over just a couple of these just so we can find some values here. Some of the more common problems that people had were on like 7 and 8. Okay, so here's number 7. Okay, I'm going to highlight a couple of these sides. This side here, this 35 centimeters, this matches the 21. Those are corresponding side lengths. Now, if those correspond, this 20 and this X correspond. They're matching sides. So they have to be matching sides. If they're not corresponding side lengths, it's not going to work. Okay, so what I'm going to do is I'm going to find my known side lengths. Okay, this 35 to the 21. I'm always going to be going towards my variable. Okay, I'm always going to be going towards my variable. 20 to X. Always in that direction towards the variable. Okay, I'm going to use my known values first. I know that 35 times something equals 21. Okay, 35 to 21. Okay, and when I do that, I know that should match my 20 to X. That means 20 times the same something, these two should be exactly the same, will equal my X value. Okay, so I just got to figure out what this number is. Now that number is easy to figure out. I just need to do a little bit of moving some numbers here. 21 over 35. Okay, that's my number. Okay, 21 over 35. Now, if that's 21 over 35 and I reuse that number over again, I'm just going to use the same number. I'm going to use this 21 over 35 and I'm going to bring it down there. I'm just going to reduce it. So 21 and 35 can be reduced both by 7. I can call that 3 over 5. Okay, now to find X, I just need to do 20 times 3/5. Now 20 times 3/5 is a lot easier than it looks. The 20 and the 5 can be reduced to 4 over 1, and 4 times 3 is 12 over 1 equals X. So for this one, we got X equals 12 centimeters. Okay, I'll do that one more time with question number 8. Okay, if you need to, pause, rewind as I go through this, because I know I go through it fairly quickly. Okay, number 8, I'm going to do much of the same things. I'm going to highlight my corresponding side lengths. X should match my 14. Those are matching pairs. Okay, and then I've got 20 and 60. Those are corresponding side lengths. Again, I'm always going to go towards my variable. So 20 to 60, and then I'm going to do 14 to X. Small to big both times. Okay. Again, I'm going to start with my known values. I know that 20 times something equals 60. Okay. And I'm going to use that same number for my green numbers, which is 14 times something equals my X value. Okay. Now this one, when you guys see this, most of the time people are like, oh yeah, that's 3. Well, yeah, we know that's 3. So what I'm going to do is, with this 3 here, I'm going to figure out how we got that 3. Okay, this 3. How did we get this 3? Okay, it's important to figure out, how did that 3 come about? So this 3, okay, I'm going to rewrite that 3 down here, came from these two numbers, 60 over 20. 60 over 20. 60 divided by 20 made 3. So I can reuse these numbers. These are the same. Therefore, I'm going to reuse it again. 14 times 3 will give me my x. 14 times 3, that's 10 times 3 is 30. And then 4 times 3 is 12. So I'll call that 42 equals x. So x here is 42 meters. Good? Again, pause, rewind if necessary. This item here, very important, this is called scale factor. Right here. This number, this number, this number is all my scale factor. Okay. For what did King also the answer over here is oatmeal. And this one here is what did King Crumb call the royal math and science teachers? It's his favorite subjects, right? Because whose favorite subject is not math? I don't know. So this is my shaded, that's my shaded one right there. Okay, make it a little bit darker. Right, there's my shaded one. Now, I need to find some sort of ratio between my numbers. So if I find a comparison, long side, long side, long side, long side, it should match my ratio of short side, short side, short side, short side. Okay. So how does 3 become 4? I don't know. Does that same way? That's plus. It's plus 1, plus 1. No, that doesn't work. I don't add to find my scale factors. That one is out. Okay. 3 to 6, that's times 2. And if I did 5 times 2, that does not equal 8. So that one is also out of the running. That leaves me with the last one, which I think works out fine. So let's check. 5 to 10 is times 2, and 3 to 6 is also times 2. It's this one. Okay. I have to find matching scale factors. If I don't, then I don't find similar drawings. Okay. So this one here, what I noticed is a lot of people misinterpreted this question for number 4. Okay. It says the two figures are drawn on dot paper at the right. Are they similar? Not similar, because either the angles or the side lengths. So let's figure this out. This one here is going to be a value of 2, and then this side length here is going to, let's just do the same color. So this is going to be 4, and then I'll match these two as corresponding, this one. And some people are like, where did you get that 2 from? Again, we're counting spaces. 1 space, 2 space, 3 space, 4 space, 5. Okay, so not the dots, not 1, 2, 3, 4, 5, 6. No, because I don't count spaces. Dots, I count spaces. 1, 2, 3, 4, 5. So this one is 5, and this is 1, 2, 3, 4, 5, 6, 7. Okay, so are these going to be proportional? Well, 2 to 4 is times 2. And then 5 to 7 is not times 2. So if they're not the same, they're not similar. Okay, so they are not similar. Okay, and it's not because of their angles, because they all have 90 here. They all have 90, 90, 90. It's because their sides aren't proportional. Okay, so this one's E. Okay, this one is going to be false. A lot of people got that one wrong. This one is true. Okay, triangles can only be made one way, whereas quadrilaterals aren't. Okay. For 7, it says ABC to EFG, so it's going from big to small. But I think this is backwards. This should actually be the other way around, because none of these are smaller. They're all bigger. So I should be going in the other direction. So we should be going from 4 to unknown. The only ones that match here are going to be the 16 and the 24. So if I get bigger from 16 to 24, 16 times something equals 24. That's 24 over 16. And if this is my scale factor, 24 over 16 reduces down to, divide each one of them by 4. No, each divided by 8. So that's going to be 3 over 2. Okay, divide that by 8, 3, yeah, okay. And then side lengths, corresponds to CD. So if I put CD together, it should match GH. Okay. Then the next one says which side corresponds to GF. So here's GF or FG should be BC. Okay. And then we've got, let's do brown. Angle A, here's angle A, should match E. They go in order. Okay. All right, so those are the ones that people had most of the trouble with on their homework. Again, I know I went through it quickly. Pause, rewind, play again, whatever you need to. Okay. Go ahead and add this to your notes. 4.1, similar ratios with similar parallelograms, page 20. Okay. Pause. So I know you guys are writing this down to your table of contents. All right, so as you're playing it, we're going to go to 4.1. This is already printed out for you. Okay, now don't cut this up. Don't put this in your notebook yet. I'll show you how to put this in your notebook without chopping this all up, because you're going to use both sides, front and back. Okay, so again, I'm going to use some of the closed reading strategies so we can kind of get a better idea of what's going on here. So it says, let's do blue because I already have it on red. What information does the ratio? Now we've talked about ratios before and we'll talk about it again. So we need to know what a ratio is. Okay. Now adjacent side lengths. Now adjacent side lengths is another one of our vocabulary words, but I underlined it because it's more of a descriptor of of where these parts are, because this is more of an English term, but that's okay. Within a parallelogram provide you. So what does this tell us? What does the side lengths tell us about these items? Okay, so we've got adjacent side lengths. This is 2, and the words we're looking for here are going to be, let's leave blue, it's going to be 2 sides that meet at a vertex. Okay, for example, you don't have to highlight this. I'm just going to show you what I'm talking about. Okay, this side length and this side length, those are adjacent. Okay, this side length and this side length, they're adjacent because they meet at a vertex. Okay, now if they don't meet at a vertex, then they're not adjacent. Okay, that's what adjacent sides are. A ratio is a comparison of 2 quantities, only 2 quantities, not any more, not any less. Okay, now since I'm talking about adjacent side lengths and ratios, we're probably going to make a ratio of these 2 numbers because they're next to each other. That's what our title is telling us. Okay, equivalent ratios. Equivalent ratios are ratios whose fractions representations are equivalent. So this is ratios whose fraction representations are equivalent. Now I'm not using the word congruent here because we're talking about a numerical value. Congruent is talking about shapes, okay? And we're talking about numbers here, numbers specifically. Okay? All right, proportion. Proportion is an equation. This is very important. Here, they're talking about the word equation, okay? Now, this is an equation that states that 2 ratios, what do we know about 2 ratios? 2 ratios are going to be considered equivalent ratios if they're equal. That are, in this case, it is talking about equal ratios. That are 2 equations stating that 2 ratios are the same or equivalent. I just don't want to write equivalent twice. Oh, sorry, not equivalent. Let me fix that. That are equal. That's the word I was looking for. Okay, now here's an example. Here are equivalent ratios. 1/2 and I don't know, 3/6. Both of those are equivalent ratios. They represent the same thing, 1/2. Now, once I put an equal sign in between it, now this is a proportion. Okay? If it doesn't have this equal sign here, it's just equivalent ratios. Once I put in this equal sign, now it's a proportion. Okay, you can pause the video and go through question A. Take about 5 or 10 minutes. A, it's got quite a few parts to it, but if you're working hard, it doesn't take you that long. Okay. Then, once you're done, you can play the video. You can see how the questions are worked out. Okay, so go give it a pause, work on it a little bit on your own, and then the sub will play it in a little bit. Okay, so this is after you've paused the video. You can follow along and see what it looks like. Which rectangles are similar? So there are actually three rectangles that are similar. Okay, A, C, and B. These are all similar. Okay, I'll show you why. I'm highlighting this side, this side, this side, and this side. I highlighted all the short sides. Now I'm highlighting all the long sides. Okay, I have to make sure that I'm comparing long to long, short to short. Okay, so if I compare each one of these, okay, 6 to 12 is times 2, and then I also have 10 to 20 is also times 2. If these two are the same, then they are similar. Okay, now let's check some more. Okay, so I'm going to try this again. I'm going to go from 6 inches to 9 inches, and then I'm going to go from 10 inches to 15 inches. Okay, now 10 to 15 is times 1.5, and 6 to 9 is times 1.5. These two, again, are the same. If they're the same, then they are similar. Okay, now that pretty much answers our question that we were looking for, but let's just check to make sure that we didn't miss anything. Okay, and I'm going to check only one of them to this to rectangle D. So 6 to 6 is times 1. 10 to 20 is times 2. Are these the same? No. So they are not similar. Okay, that's simple. All right, so we know that similar triangles are A, B, and C. I'm just going to write that off to the side over here. So I'm going to say triangles A, B, and C. Oops, that's not a C. A, B, and C are similar. Okay, it says for each rectangle, find the ratio, there's that word ratio, of the length of the short side to the long side. All right, so I need to find the ratio of long side to short side, or short side to long side. It doesn't really matter. So I'm just going to do, it says short side first, so I'll do the short side. So yellow, that's short, over the green, which is long. Okay, so I'm going to label these. This is my short side. This is my long side. Okay, now my short side for rectangle A, I think I've been saying triangle, rectangle A, rectangle B, rectangle C, and rectangle D. So long to short. Long for A is, sorry, short for A is 12, long for A is 20. Short for B is 6, long for B is 10. Short for C is 9, long for C is 15, and then D we have 6 over 20. Okay, now it says, okay, find the ratio. Cool. Now it says, what do you notice about the ratios in part A for similar rectangles? Okay, so let's identify our similar rectangles really quickly. I know that this one this one, and this one are similar. Well, what do you notice about their ratios? Well, let's find a relationship between these two. If I reduce this, I get 4/5. If I reduce this one, I'll divide that by 4. Oops, sorry, that should be 3/5. 3/5. If I reduce this one by 2, I get 3/5. And if I reduce this one, I get 3/5. If I reduce this one, I get 3/10. This one is kind of a little bit different. So, what do you notice about the ratios for part A about similar rectangles? Okay, so similar rectangles have proportional. Okay, there's that word that we use, proportional. Proportional, which means that their ratios are equal. Okay, so similar rectangles have proportional side lengths. Good. Very important to know that the side lengths are proportional. That works specifically for rectangles. Choose two similar rectangles and find the scale factor from the smaller rectangle to the larger rectangle. Okay, we did that already. We did from B to A, from smaller to larger, just like it asked. And the scale factor was ×2. So let's write rectangle A and rectangle B. Rectangle A had a ratio of 12. Oops, sorry, I got that backwards. Let's erase this. Got this backwards. Let's do B first. We went from B, the small, to A, the large. Okay, and our ratios were 6/10, and A was 12/20. Now, it says find the scale factor. We know our scale factor was ×2. And what does the scale factor tell us? It tells us, so what does the scale factor tell you? So the scale factor tells you how much each side length increases. Okay. All right, number 4 says, compare the information given by the scale factor in part 3 to the information by the ratios of the side lengths in part 2. Compare the information given by the scale factor in part 3, here's my scale factor in part 3, to the information given by the ratios of side lengths from part 2. Okay, I think we already did that, but let's rewrite it anyway. So compare the information by the scale factor from part 3 to the given information by the ratios. Okay, so we go from B to A, and then we have short 6 times scale factor 2 equals 12 over long, which is 10 times 2 equals 20. So it kind of ends up being the same thing. Okay. All right. B, I'm going to go through this quickly, just so you guys have enough time to see everything. It says which parallelograms are below are similar. So this one's actually, again, you can pause it and go through it, but for the sake of time, based on the length of this video, I know it's going to be a while. So I know that this one and this one are the same. Therefore, this one's out. Okay. Similarity has to have the same angles. And those angles are the same, and that one's not. Okay. So I already know that those two are similar, and the other one isn't. Okay. So which of the parallelograms are similar? I'll say F and G are similar because they have congruent angles. Okay, now it says for each parallelogram, find the ratio of the side lengths of long to short. So I'll do the same thing we did before. Here's my short side, short side, short side. Here's my long side, long side, long side. Okay, and it says long side, so I'll do long side first. Long side over short side. Okay, so long side is, I'll label this as long, I'll label this as short. Okay, here's E, F, and then G. E is 10 over 8. F is 7.5 over 6. This is 6 over 4.8. And I've already reduced each one of these once before. This becomes 5/4. This becomes 5/4. And this becomes 5/4. So how do the ratios compare? All the ratios are equivalent. Okay. Now suppose you find the ratio of the side lengths of adjacent sides, where two sides meet a vertex, in a rectangle. This ratio is equivalent to the ratio of the corresponding side lengths in another rectangle. Are these going to be similar? Okay. So for this one, yes, because rectangles, and this is important, rectangles, and they use this word here, rectangles, have all 90-degree angles. Okay? Because the side lengths are going to be proportional, and all the side lengths are going to be 90 proportional from short to long or long to short, they should all be similar to each other. For C2, it says suppose you find the ratio of side lengths of the adjacent sides of a parallelogram, okay, and the ratios are equivalent. Does that mean that they are similar? I would say not always, because the angles need to be the same. And they're not always the same. In this case, they were not all the same. Right? Okay, you're going to take your quiz. Again, just put this into your notebook. We'll go over it together. I'm going to show you what your quiz looks like and a couple of things we want to write on there so we don't get confused. Okay, so sub should pass out your quiz. Okay, so this is your quiz, your group quiz. A couple things to note. It tells you each point value for each question. And I'm just going to go over a couple of the questions really quickly because a lot of people got confused. So here, this is Ashley's drawing. This is Ashley's drawing. This is Ashley's drawing. So Ashley's drawing used this rule. Okay? That's what it's telling you. That's Ashley's drawing. You have to figure out what Ryan's drawing is if this is Ashley's drawing. So you're trying to figure out Ryan's drawing if Ashley used a 3x 3y rule. Okay? So you got to redraw Ryan's drawing before Ashley expanded it to 3x 3y. Okay? It's about as much help as I can give you there. Okay? And then it gives you information here about Simone's drawing. So it says Simone saw Ashley's drawing and doubled all the lengths. So Simone doubled all the lengths when she saw Ashley's drawing. Okay, so keep that in mind. All right. Down here where it says, are the shapes A and B similar? There should be protractors on your desk. There should be about 3 per table. You have to determine if these two are similar, if A and B are similar, and why they are or aren't. Okay? Use your protractor okay, if you need to. So use protractor. Maybe you might need a ruler. Okay, you have rulers in your planners along the edge. You don't need to go get another one. Okay, and you need to determine if these are going to be similar or not. Okay, in your explanation, you have to mention some of these items. Okay, if you don't, it's not going to be correct. Okay, now number 3 is important. It says Megan wanted to make a new video game character. Use LabSheet 2.1. Now you have 2.1. Yes, you are allowed to use your notebooks during your quiz. Okay, this is the one with mug, bug, and zug, glug, and lug. Okay, that's this one where we drew them out. Okay, some of you guys did a really good job. There's a video on this as well. Okay, now it's just telling you to reference this piece of information. Okay, you're going to write a rule. You're going to write your own rule that's going to transform, it's going to change mug into slug. Slug is new. He's not yet created. You must create him. You don't actually have to draw him. You just have to create a rule that makes slug. Okay, he is not yet created. Okay, so don't look there and think, which one is slug? He's not in there. You're writing a rule that creates slug. Okay, and then we'll grade them when you come back, when I come back, or next class. Okay, your homework again is that half sheet of paper that you picked up on the way in. And please be on your best behavior. I want to have a good report from the sub saying how wonderful you guys all were. Oh yeah, last but not least, this is a partner quiz. You can work on your table. This should say group quiz. This should say group. You can work with the table, not just your partner. Okay.